Did you know that Euler, one of the greatest mathematicians of all time, was nearly blind for half of his career? Despite his vision impairment, Euler's mathematical contributions never faltered. His prodigious memory and mental computation skills compensated for what he could no longer see. He continued to solve complex problems and create theories that have shaped the world of mathematics as we know it today. Euler's determination and passion for mathematics was so strong that not even near blindness could stop him. Born in Basel, Switzerland in 1707, Euler's mathematical journey began at a young age. His father, Paul Euler, a Protestant minister with a keen interest in mathematics, was the first to introduce him to the subject. The seeds of curiosity were sown in Euler's mind, and he began reading mathematical texts independently, supplementing his father's teachings with his own explorations. Despite attending a school that offered no formal mathematical instruction, Euler's passion for the subject didn't wane. Instead, it was fueled by his father's teachings and his own thirst for knowledge. But life had a different plan for young Euler. Following his father's wishes, he was sent to the University of Basel to prepare for a life in the ministry. At the age of 14, Euler embarked on his university journey, initially pursuing general education before delving into more specialized studies. It was here that he crossed paths with Johann Bernoulli, a renowned mathematician who recognized Euler's potential for the subject. Despite his busy schedule, Bernoulli advised Euler to study complex mathematical books on his own and offered to clarify any difficulties during their weekly Sunday meetings. Euler's dedication to mathematics didn't go unnoticed. In 1723, he completed his master's degree in philosophy, comparing and contrasting the philosophical ideas of Descartes and Newton. But his heart was still drawn to the world of numbers and equations, not theology, Greek, or Hebrew. With Bernoulli's persuasion and Euler's persistent passion, his father finally gave his consent for Euler to switch his studies to mathematics. It was a pivotal moment for Euler and mathematics as a whole. The fact that Euler's father and Bernoulli were old university friends undoubtedly eased this transition. Upon completing his studies at the University of Basel in 1726, Euler had already begun making his mark in the world of mathematics with his first published paper. With Johann Bernoulli's encouragement and his own passion for the subject, Euler embarked on a mathematical journey that would leave a lasting impact. Even before completing his studies, Euler was already making waves in the mathematical world. This prodigious mathematician started his journey in the world of academia with a bang. He was just a student when he published his first paper. This wasn't a simple class assignment or a minor research paper. No, it was a profound exploration of isochronous curves in a resisting medium, a topic that would make even seasoned mathematicians pause. Picture a young Euler burning the midnight oil, consumed by the elegance of these curves that maintain a constant period regardless of amplitude. But Euler didn't stop there. He continued to explore the fascinating world of mathematics, publishing another paper on a complex topic: reciprocal trajectories. Imagine a cannonball flying through the air, its path determined by the laws of physics. Now, imagine reversing that path, making the cannonball trace its way back to the cannon. That's the essence of a reciprocal trajectory. Euler's work on this topic showcased his ability to blend mathematical theory with physical phenomena, an ability that would serve him well throughout his career. Euler's early contributions didn't go unnoticed. In fact, they caught the attention of the Paris Academy, a prestigious scientific institution. Euler submitted an entry for the Grand Prize of the Paris Academy in 1727. This was a highly competitive event, attracting entries from the brightest minds in Europe. Despite the stiff competition, Euler's work stood out, further establishing his reputation as a rising star in the mathematical field. These early works were just a glimpse of the brilliance that was to come from Euler. His initial contributions were like the first rays of dawn, heralding the arrival of a brilliant day. In Euler's case, that day would be filled with mathematical discoveries that continue to shape our understanding of the world even today. So, stay tuned as we delve deeper into Euler's major achievements in our next segment. Euler's contributions spanned numerous areas of mathematics and physics, each as groundbreaking as the last. Let's start with analytic geometry, a field that combines algebra and geometry to study the geometric properties of sets defined by algebraic equations. Euler was instrumental in developing the concept of a function and introduced much of the modern mathematical terminology and notation. He solidified the use of the Greek letter sigma for summations and the letter e for the base of the natural logarithm. Then there's trigonometry, the study of relationships between angles and sides of triangles. Euler's formula, which states that e to the power of any imaginary number is a point on the unit circle, is a cornerstone of this field. It links 5 fundamental numbers in one simple equation, ip plus 1 equals sine 0. This formula has been described as the most remarkable formula in mathematics, a testament to Euler's genius. In geometry, the study of shapes and their properties, Euler's gem stands out. Also known as Euler's polyhedron formula, it describes a relationship between the number of vertices, edges and faces of a polyhedron. Simply put, if you take any polyhedron, count the number of corners, edges and faces, and then subtract the number of edges from the sum of corners and faces, you will always end up with the number 2. When it comes to calculus, the study of change and motion, Euler made significant strides as well. He introduced and standardized many of the concepts and notations used today, such as the notation fx for a function and its value at x, and the d symbol used in differentials. Last but not least, in number theory, Euler pioneered the use of analytic methods to solve number theory problems, effectively inventing the field of analytic number theory. He discovered the prime number theorem, which gives an approximation for the number of primes less than a given value. He also introduced Euler's totient function, which counts the positive integers that are relatively prime to a given number. These are just a few highlights from Euler's extensive list of achievements. His work in these fields has had profound and lasting impacts, shaping the way we understand and apply mathematics today. His formulas and theorems have found applications in various fields, from physics to engineering, from computer science to economics. Euler's work laid the foundation for many areas of modern mathematics. His ability to make complex concepts understandable, his knack for finding connections between different branches of mathematics, and his sheer productivity have made him a legend in the field. Indeed, Euler's legacy is a testament to the power of curiosity, rigor, and ingenuity in the pursuit of knowledge. Despite personal hardships, Euler's later life was as productive as ever. Around the age of 50, he began to lose his sight, an event that would have halted many in their tracks. Yet for Euler, this was merely a bump in the road. He continued to produce groundbreaking work even after becoming almost completely blind. His determination was unshakable, his mind as sharp as ever. Euler's ability to perform complex calculations and formulate intricate theories in his head was nothing short of remarkable. As Euler aged, his reputation grew. He was respected and admired by his contemporaries, and his work was widely read and studied. His prolific output did not wane, even in his final years. He continued to publish despite his failing health, right up until his death in 1783. Euler's death marked the end of an era, but his legacy was far from over. His work continued to resonate, influencing generations of mathematicians who came after him. Euler's contributions to the field were manifold. His work in analytic geometry, trigonometry, calculus, and number theory laid the groundwork for much of modern mathematics. He introduced many of the symbols and notations we use today, making mathematics more accessible and easier to understand. Euler's influence extended beyond mathematics. His work in physics, particularly in fluid dynamics and optics, was also groundbreaking. He made significant contributions to astronomy, paving the way for future discoveries. His work on the three-body problem in celestial mechanics is still considered a cornerstone of the field. Euler's life was marked by an unyielding commitment to the pursuit of knowledge. His work ethic, his relentless curiosity, and his ability to overcome adversity are as inspiring as his mathematical achievements. He was a trailblazer who refused to be limited by circumstances, pushing the boundaries of what was possible in his field. Euler's life and work continue to inspire mathematicians today, a testament to his enduring impact on the field. Leonhard Euler was more than just a mathematician. He was a trailblazer. Born in Switzerland, Euler's passion for numbers led him to make monumental contributions across multiple branches of mathematics and physics. His relentless curiosity and determination propelled him to pioneer fields like analytic geometry and calculus. But beyond his formulas and theories, Euler's story is a testament to the power of passion, the human spirit, and their capacity to revolutionize understanding. Euler's story is not just about mathematical formulas and theorems, it's about the power of passion and the human spirit.